Hello, future engineers, subscribers, viewers, and students. So here are problems in Algebra 3, 4, and 5. This is part 3. These are problems given as quiz in our course. The roots of the polynomial p of x, ao x to the n plus a1 x to the n minus 1 plus a sub 2 x to the n minus 2 until the constant term are 3 halves, quantity 2/3 plus square root of 3i over 3. Find the coefficient of the first degree term. So by principle, because we have one root which is 2/3 plus square root of 3i over 3, the other root is 2/3 minus square root of 3i over 3. Therefore, this polynomial is third degree. And I will find the coefficient of the first degree term. So this is written in factored form as, so 2/3 minus square root of 3i over 3 is also a root. That's why this polynomial is third degree. So writing this in an expression such that the root is 3 halves, so that is 2x minus 3. P of x is 2x minus 3. And for this part, we have 3 times quantity x minus square root of 3i, and the other root is 3 times x minus 3 times x plus quantity 2 plus square root of 3. In factored form, we have quantity 3 minus quantity 2 minus square root of 3i, and the other root is, the other factored form is 3 minus quantity 2 minus square root of 3i. So 3x minus quantity 2 plus minus square root of 3i. So this is for this root, for these two roots here. So simplifying, p of x is 2x minus 3, quantity 3x minus 2, then minus square root of 3i, 3x minus 2 plus square root of 3i. So p of x is quantity 2x minus 3, then quantity 3x minus 2 square plus 3, because negative square root of 3i times positive square root of 3i is negative 3i square, but I square is negative 1, so negative 3 times negative 1 is positive 3. So p of x is quantity 2x minus 3, 9x squared minus 12x plus 7. So square of the first, twice the product, so negative 12x. Square of the second, 4 plus 3, 7. Then distribute. P of x is 18x squared minus 24x squared, 18x cubed rather, and minus 24x squared, and 2x times 7 plus 14x minus 27x squared, then plus 36x, then negative 3 times 7 minus 21. So simplifying, we have 18x cubed minus 51x squared plus 50x and minus 21. So therefore, the coefficient of the first degree term is 50. So the answer is 50. The description of the roots of the equation 2x to the fifth minus 6x to the fourth minus x squared plus 4x minus 1 equals 0 is. So let's have by Descartes' rule of sign. So let's determine the number of variations in signs. P of x is 2x to the fifth minus 6x to the fourth minus x squared plus 4x minus 1. So this is the first variation, second variation, then third variation in sign. Therefore, the number of positive roots is 3 or 1. Then P of negative x is 2 times negative x to the fifth minus 6 times negative x to the fourth minus quantity negative x squared plus 4 times negative x minus 1. So this is negative 2x to the fifth minus 6x to the fourth minus x squared minus 4x minus 1. So there's no variation in signs. So 0, therefore there's no negative root. So 0 negative root. So therefore, the possible roots would be 3 positive roots, 0 negative roots, and 2 imaginary roots. Or 1 positive root, 0 negative root, and 4 imaginary roots. So again, one possibility is 3 positive roots, 0 negative roots, and 2 imaginary roots because the degree of the polynomial is 5. We expect 5 roots. So if there are 3 positive roots, then 0 negative roots, this is definite, and therefore 2 imaginary roots. The other possibility is 1 positive root, 0 negative roots, and 4 imaginary roots. So based on the results and from the choices, the answer is letter A. So 3 positive roots, 0 negative roots, and 2 imaginary roots. Decompose the fraction into partial fraction. And then find the sum of the unknowns in the numerator of the decomposed fractions. So we have quadratic factors. So 3x squared minus 4x over x squared plus 1 times quantity x squared minus x minus 1 equals ax plus b over x squared plus 1, then plus quantity cx plus d over x squared minus x minus 1. Multiply everything by the LCD, which is this. So we have 3x squared minus 4x equals quantity ax plus b times x squared minus x minus 1 plus quantity cx plus d times x squared plus 1. So we expand 3x squared minus 4x equals ax cubed minus ax squared minus ax plus bx squared minus bx minus b. Then plus cx cubed plus cx plus dx squared plus d. We equate coefficients of x cubed. So we have a plus c. We equate coefficient of x squared. So 3 equals negative a plus b plus d. We equate coefficients of x. Negative 4 equals negative a minus b plus c. Then constants 0 equals negative b plus d. So That means B equals D. And from here, A equals negative C, or C equals negative A. So from this equation, 3 equals negative A, because B equals D, we replace D by B. So 3 equals negative A plus 2B. Call that equation 2A. Then from this equation here, replace C by negative A. So negative 4 equals negative 2A minus B. We multiply this by 2. So negative 8 equals negative 4A minus 2B. Call that equation 3A. Then we add equations 2A and 3A. So that 3 plus negative 8 is negative 5. Then negative 5A equals negative 5A. So from there, A is 1. And because C is negative of A, C is negative 1. B equals D. B equals D equals 2. And that is from this equation here. Because 3, A is 1, so 3 plus 1 is 4. 4 divided by 2 is 2. So B, which is equal to D, equals 2. And C equals negative 1. So therefore, A plus B plus C plus D equals 1 plus 2 plus negative 1 plus 2. Cancel 1 and negative 1. So 2 plus 2 is 4. So A plus B plus C plus D equals 4. 15 for the polynomial of 6 degree with 3i as roots of multiplicity 2 and 2 minus I square root of 2. Find the coefficient of the second degree term. So by principle, if one root is 3i, the other root is negative 3i. And if we have 2 minus I square root of 2 as one root, the other root is 2 plus I square root of 2 by principle. Since 3i and negative 3i have multiplicity of 2, therefore in an expression, it is x squared plus 9, then quantity square, because the multiplicity is 2. And this one, x minus quantity 2 minus I square root of 2, and x minus 2 plus I square root of 2. So P of x is x squared plus 9 quantity square, then times x minus quantity 2 minus I square root of 2, and x minus quantity 2 plus I square root of 2. So P of x is x to the fourth plus 18x squared plus 81 times quantity x minus 2 squared plus 2. So negative, because we have positive I square root of 2 times negative I square root of 2. That's 2I squared, and I squared is, that's negative 2I squared rather. And I square is negative 1, so negative 2 times negative 1 is positive 2. So expanding this second factor, x to the fourth plus 18x plus 81 times quantity x squared minus 4x plus 6. 4 plus 2 is 6. P of x is x to the 6 minus 4x to the 5th plus 6x to the 4th plus 18x to the 4th minus 72x cubed. 18 times 6 is 108x squared and 81x squared. 81 times negative 4 is negative 324x. 81 times 6 is 486. Simplifying, combining like terms, p of x is x to the 6 minus 4x to the 5th plus 24x to the 4th minus 72x cubed plus 189x squared minus 324x plus 486. Therefore, the coefficient of the second degree term is 189. 16. An integer of 3 different digits is to be formed from the digits 1, 2, 3, 4, and 5. So 5 different digits. What is the probability that it is less than 325? So this is the number of favorable outcomes. Let's have 310 less than I less than 320 first. And it is less than 325, of course. So we find the number of different of 3-digit integers between 310 and 325, which is less than 325. So of course, the first position is 3. So there's only one 3. So there's only one way to assign a digit here, which is 3. Specifically 3. Then after we place a number there, the next should be 1. 310 to 319. So 1. That one left. So there's only one way to assign a digit here. Then 2 digits are already positioned, 3 digits left. So there's 3 ways to assign a digit here. So 1 times 1 times 3 is 3. Next is between 320 and 325, NF2. So there's one way to assign a digit here because it is 300 plus, 320 plus. So that's 1. That is 3. The digit 3. There's one way to assign a digit here, which is 3. Next is a digit 2. So there's also one way to assign a digit here. And 3 digits left, but 5 is not included, so 2 digits left. So we can only assign 2 digits, 2 ways here, because 5 is not included. So 2. Then if it is less than 300 or 310, so if it's less than 310, so we can only assign the digits 1 and 2 here, no longer 3. So 1 and 2. So there are 2 ways to assign a digit here. Then after we assign a digit here, 4 digits left. So there are 4 ways to assign a digit here. Then after assigning a digit here, 3 digits left. So there are 3 ways to assign a digit here. So 2 times 4, 8 times 3, 24, plus 5, 29. So the total number of outcomes is the permutations of 5 different digits taken 3 at a time, or 5 times 4 times 3, or 5p3. That's the same. So it is 60. Therefore, the probability that the three different digits is less than 325 is 29 over 60. If 10 students are assigned seats at random in a row of 10 chairs, what is the probability that a certain 2 students will be seated next to each other? So this is permutations by group. So let's group the first 2 students, then the rest of the students will have 1 member each. So 2, 4, 6, 8. There are 9 groups. So the number of favorable outcomes is number of groups factorial, then times number of members of the first group factorial, then second group, third group factorial. So 9 factorial times, there are 9 groups, so 9 factorial. Then this group has 2 members. We can arrange the members within that group into 2 factorial because there are 2 members. The rest would be 1, 1, 1, 1, 1. So it does not affect. So 9 factorial times 2 factorial over 10 factorial. There are 10 students, so they can be arranged in a row in 10 factorial ways. So the probability is equal to 1/5. A committee of 5 is to be chosen at random from a group of 4 Republicans and 5 Democrats. What is the probability that the committee will contain exactly 2 Republicans and 3 Democrats or all Democrats? Because of this or, then we have to add. So 2 Republicans and 3 Democrats is the selection of 2 Republicans from 4 and 3 Democrats from 5. And that is combinations. So 4 combination 2 times 5 combination 3. All over, there are 9 persons here. So 9 combination over 9 combination 5. Then plus 5 combination 5 over 9 combination 5. So probability is probability that the committee contains exactly 2 Republicans and 3 Democrats, plus probability that all 5 would be Democrats. So in this case, it is 4 combination 2 times 5 combination 3 over 9 combination 5 plus 5 combination 5 over 9 combination 5. So this is 10 over 21 plus 1 over 126, adding, so it is equal to 61 over 126.